So evaluating limits of the functions you know about, polynomials, radical functions, rational functions, substitute, simplify, assuming things are defined. There's one other I didn't mention in the previous video, but it falls in this case category as well. Composition, when you do composition of functions. That allows you to have functions within functions, and so the limit of a composition is the composition of the limit. The net effect is, if for any function in your experience of those varieties, you substitute, simplify, you plug and chug, you substitute, you simplify, and the result you get is the limit that you're looking for. Right now, all we're looking for is how to find the limit. We're not worried yet about how come. We're not worried about why we're doing this and what's it good for and what does it lead to. For now, we're just simply dealing with how do you find the limit, all right? Well, there's another category of functions that you've dealt with, and it turns out they're also in the fold. The trigonometric functions. All right? And so we have 6 new functions to play with. Now the limit x approaches a of tangent of x. We have the limit x approaches a of cotangent of x. Limit x approaches a of secant of x. And limit as x approaches a of cosecant of x. And it turns out, this is not obvious. We could go through a proof of this. We're going to forgo that. But for the record, limit as x approaches a of sine of x is sine of a. Substitute and simplify. Substitute a in for x and crank it out. And that is true for the other 5 as well. Limit as x approaches a of cosine is cosine of a. So the trigonometry, you also substitute, simplify. Trigonometry, how do you find the limit of a trigonometric function? You substitute, simplify, you plug and chug. Substitute the value, evaluate it in. This is tangent of a. This is cotangent of a. This is secant of a. This is cosecant of a. Now, there's one caveat. Remember, tangent is undefined for certain values. Cotangent, cosecant, secant, these are undefined for certain values. So this is assuming the function are defined there. So we are assuming the functions are actually defined at those values. If cotangent does not exist at a, then this limit is not equal to that. If secant is undefined at a, then this limit is not equal to that because there is no value for it to equal. This can get more subtle later on, and it does get more subtle later on. But these properties are true. The limit of assuming the value is in the domain, of the function, then the limit as x approaches a value for any one of the 6 trig functions is you substitute, simplify, and you're out. So let's do some specific cases here. Let's do some specific current occurrences here. What's the limit as x approaches pi over 2 of sine of x? Well, substitute. That's equal to 1. Sine of pi over 2 is equal to 1. What's the limit as x approaches pi over 4 of tangent of x plus cosine of x? There we go. Now let's do cosine 4x. Well, we know the limit of the sum is the sum of the limits. We know the limit of the composition is the composition of the limits. And so the net effect is, assuming everything is defined, substitute, simplify, see what you get. So, always, and it doesn't matter how far into the math courses you go, if you're asked to evaluate a limit, your first run up the hill, the first thing you try is plug and chug. Substitute, simplify. That's the first thing you try. If that works, you're done. If it doesn't, there are more advanced tools to handle some things. First thing you try, the card you lead with your aces. And your aces are, in this case, substitute, simplify. So this is equal to tangent of pi over 4 plus cosine of 4 times pi over 4. And what do we know? Tangent of pi over 4, we know that's equal to 1. And this is cosine of pi. And we know that's negative 1. So this is 1 plus negative 1. Turns out that's equal to 0. Big deal. The specific number is irrelevant. What matters is the overall principle. Substitute, simplify, you're out. Assuming you get an answer. Now, suppose we do something like this. Suppose we want the limit x approaches pi over 2 of secant of x. Well, the first thing you try is I want to try secant of pi over 2. You think, oh, I don't remember how to do secant of pi over 2. Oh, yes, you do. That's 1 over cosine of pi over 2, which is 1 over 0. Uh-oh, that does not exist. And you might as well go ahead and join the club. Anybody who knows what you're doing knows DNE means does not exist. Or you could say there is no limit or it has no value. But DNE is the standard abbreviation. I will use this freely all over the place. DNE means does not exist. So the limit as x approaches pi over 2 of secant of x does not have a value. Because if it did, we'd have found it. All right? So for the functions that are in your realm of experience that we've covered so far, polynomials, rational functions, radical functions, the trigonometric functions, the composition of functions, all those basic kinds of functions. What these properties, the net effect of all these properties, it's less important that you have each individual property memorized. That's not a big deal. That's not what I'm after. What I'm after is, if I give you a function like this and say evaluate, or give you a function like this and say evaluate it, you know what to do. And you know that the net overall effect is, first thing you try is substitute, simplify. If that works, you're done. If it doesn't work, then there are some other tools we can use. And that's what we're going to be on about here pretty soon. So, substitute, simplify, you're out.